So last week, we spent some time talking about um, some basic arithmetic. We talked about decimal numbers, and I emphasized that we have technology at our fingertips that we can use to quickly compute, do any computation that would involve these numbers, whether be it decimals, whether be it whole numbers, whether be it directed numbers, and the order of arithmetic operations. I think we went through that in detail. We did some nice examples, and the video is available for anyone who wants to just have a look at it again. And there are lots and lots of resources all over the internet that you can always, you want to refresh a course in maybe how to add, subtract, multiply, and divide directed numbers. There are lots of videos online. Maybe you could just watch a YouTube video dealing with it. Same thing with decimal numbers and, well, ordinary whole numbers as well, right? What I want to spend a little time on this afternoon is some other aspects of arithmetic, and I want to talk about fractions a little. Fractions, right? All of us know what we're talking about when we talk about fractions, and we talk about quantities that part of a whole, such as half, 3/8. We know what the top number is called, the numerator. Numerator. This is the denominator, right? Then you have what you call mixed numbers as well. Sometimes you see 1.5. They're reported as a mixed number. Back to fractions, you have what you call improper fractions. These are proper fractions into the numerator is actually less than the denominator. You can have an improper fraction, such as, let's say, 3/2. The numerator is greater than the denominator, right? And this can be broken up into what we call a mixed number. It's 1.5, right? How to convert from one to the other? Well, this is all a review for some of you, right? Who forget your primary school mathematics, right? You multiply the whole number by the 2 and add the numerator. You get 3, and you put it back over the denominator. And the simple reason, if you want to get into why that is so, why do you use that shortcut? 1.5 is really this. 1 plus a half. That's what it means, right? And if you were to write 1 with a denominator of 2, it will be 2/2, right? And if we add a half here, so the two common denominators, it's 2, and you just add the numerators, right? Sorry, 3 plus 1, so that's a 2, and a 3/2, right? To make it back into a mixed number, 3 divided by 2 will give you 1, and 1 is the remainder. You put that over the denominator, or the divisor 2. Are you remembering all this stuff from your maybe primary school? What do you say?
Yes, sir.
Great.
Yes, sir.
Good. So let's talk a little about how we can add fractions, how we can subtract fractions, multiply them, divide them, and so on, right? We'll also do mixed numbers as well. Like, okay, let's say you want to add 1/5 plus 3/4, or 3/4. What do? Find your LCM. Your LCM of 5 and 4 is 20, right? Then you want to write both of these fractions with this common denominator now. So you divide the 20 by 5, you get 4. 4 times 1 is 4. So 4 over 20 is actually 1/5. 4 into 20 is 5. 5 is 15. 15 over 20 is the same as 3/4, right? And then you add that, you get 19 over 20, right? And now that we're talking about that, 1/5 is the same as 4 over 20, right? You can break this down, 4 1s, 4 5s, and that's how you get that, right? That's what this piece is about. 3/4 is the same as 15 over 20, because 15 over 20, you could break that down, you could look for the highest common divisor, right? A factor of the numerator and denominator, right? 5 3s, 5 4s, and that's how you get 3 over 4, right? You following this? Is this easy? I'm just doing a quick review because
Yes, sir.
Yes, sir.
Let's say you have a mix, some mixed numbers now. Maybe you want to add 1 and 1/3 plus 2 and let's say 3/4, right? There are different ways of doing it. Okay, maybe some people will do this. They add the 1 and the 2, right? And they get 3 out here, and then they'll add the 1/3 and the 3/4. They'll find the LCM of 3 and 4, which is 12, right? And then they'll write 1/3 with the denominator of 12. So 3 into 12 is 4. 4 1 4, plus 4 into 12 is 3. 3 and 4 to 12 is 3. 3 times 3 is 9. So you have 3 and 11 over 12, right? That's your answer. Right? Some people, they do it differently. They will change these two mixed numbers into improper fractions, and they'll do it by 1 by 3 is 3, and the 1 is 4. So 4,
Excuse, sir.
yeah.
It's 13 over 12, not 11.
Oh,
9
okay.
and 4, 13.
Great. I'm happy that you are awake and in this class. I did that on purpose to see if you all are following. All right. And I'm happy this happened. I'm happy. The reason why is that you have another improper fraction here, right? So what needs to happen now is that you need to, remember you can't have 3 and 13 over 12. You have to break this up into another mixed number. So you have 3 plus 13 over 12.
And 1 over 12.
Which is 3 plus 1 and 1/12. I'm happy you stopped me there. Right? I'm not God, I can make mistake, right? Yeah. So we have 4 and 1/12. Right? Very good observation. Yeah. So
Yes,
alternatively,
sir.
we can change these into improper fractions as you see here, right? 1 and 1/3 is 4 over 3. Get that by multiplying the 3 by the 1, adding the 1 on top here. You get it 4 over 3 plus 2 and 3/4. 2 by 4 is 8 and 3, 11 over 4. Then you add them, your LCM being 12. 3 into 12 is 4, 4, 4, 16 plus 4 into 12, 3. 3 times 11 is 33. And you get what here? 33 and 16 is how much?
49.
49, right? Over 12,
Yes.
which is, again, 4 to 49, 4 12s is 48, right? So you get 4 and
4
1,
and 1.
right? This method here kind of exposes you to some fractions with very large numerators and so, you know. So you have to be careful, right? This one here exposes you to situation where you can have an improper fraction here, and sometimes you don't pay attention. Like, well, I almost did that. right? Subtraction is very similar. It's just that, well, where you have the plus, you have a minus now, right? So let's say you have to do some subtraction. 2 and let's say 1/3 minus 1 and let's go with 4/5, right? So again, you can do a couple of things. You can, okay, subtract the whole numbers. 2 minus 1, you get 1. And then you subtract 4/5 from half. So your LCM is going to be what? 10.
10.
So you have 2 into 10 is 5. 5 ones 5. So you get it minus. 5 into 10 is 2. 2 4 is 8. So you have a situation here, right? You have a situation here where you have 5 minus 8, which would be a negative, right? So every way of handling this, maybe your primary school teacher will tell you that this 1 is basically 10 over 10, right? Because the numerator here is 10. So the 1 is like 10 over 10, right? There's a plus sign here, even though we don't normally write it, plus 5 minus 8 over 10, right? And you can have now, because the numerators are, the denominators are the same, you can write this way. 10 plus 5 minus 8 over 10, that can work. And you will get what? 15 minus 8, you'll get what? 7. You get 7 over 10. That's one way. Sometimes the teacher will say, no, you take this one. Let me go from here. Take this one. This one is 10 over 10. So you take the 1. All right, strike it off. Right? And you add that 10 to the 5 minus the 8 over 10, right? And you get the same answer, 7 over 10. You follow that? Let's do one where it's not 1 in front there. Maybe it's another number. Let's do back the same one. And maybe, all right, this is a 3. Let's do back the same. We have a 3 here. Let's have a 3 here. So instead of 1 here, you have 2. There you go. So down here, 3 minus 1 will be 2 here, right? So since there's 8 is greater than 5, so what you do, you can borrow 1 from this or take 1 from here, right? And you have 1. And remember that 1 is 10 over 10. So you put 10 plus 5 minus 8. So you'll end up with 1 and 7 over 10. Right, you follow that one? We take 1 from here and we convert it into 10 over 10. It's like saying this. 2 is really 1 plus 10 over 10 plus 5 minus 8. We had a sudden influx of mosquitoes here. Give me a second. June. Yes. So in this case, we have a situation here where 8 is greater than 5. So we don't want a negative there, right? You can do that too, right? But there, it might be a little complicated and You might remember that in primary school, they never taught you about negative numbers and so that might be a little difficult for you. But we'll try it just now even with a negative there, right? That's not a problem, right? Good. So what they normally tell you to do is take 1 from this 2, right? So we get 1 here. So after we take this 1 from the 2, right? Imagine this 2 to be what? All right, let me, that 2 is like 1 plus 1 plus 5 over 8 over 10, right? 5 minus 8, sorry, over 10. So this 1 now, we can write this one as 10 over 10, that same one, plus 5 minus 8 over 10, right? Because these the denominators are the same, we can write this way. 1 plus, put all of this over 10, 10 plus 5 minus 8, and we get 1 and 7 over 10. That's one approach. But I have others. I'll show you the others. Now let's try around, and it's good to, you don't have to do it the way you were taught in primary school. Like, what would if we had a negative here? Let's see what happens. So you move this along, so you get 2. All right, you got 2, 5 minus 8 over 10. So you have that. Let's just say you take this 5 and subtract the 8, you get 2. And down here you get minus now. 5 minus 8 is minus 3 over 10, right?
Negative 3.
Is that clear?
Yes, sir.
Yes, sir.
What you could do now, you could now write 2 upon 1 minus 3 over 10. Your LCM is now 10. 1 into 10 is 10. 10 by 2 is 20 minus 10 into 10 is 1 times 3 is 3. And you end up with 17 over 10, right? That now is equals to 1 and 7 over 10. So nothing is wrong if you want to do the subtraction on top there and end up with a negative. All of that.
Yes, sir. I believe that this way you did here was more easier than the one before.
Yeah, all those are ideas. You can also do it another way. Yeah, you can choose what you want to do. Let me just go back to the question. What was the question? 3.5 minus 1 and 4, right? Let's see if I can remember. 3.5 minus 1 and 4. And again, this was probably one of the ways you were taught in primary school as well. You can change everything to improper fractions. 3 2s, 6 and 1, 7 over 2. 1 second. Yeah, so one approach to is to change everything to improper fractions. So this 3.5 will become 7 over 2. And the 1 4/5 will become 9 over 5, right? And you will proceed like normal. LCM in 10, 2 into 10 is 5, 5, 7, 35. You'll end up having some big numbers, right? 5 into 10 is 2, 2 8s, 2 9s is 18. So you should have what? Again, is 17. What was it? 17 over 10, which is 1 and 7/10, right? So those are different approaches to the subtraction, right? You choose which one you like, but back to the point, right? If you have a calculator that can do fractions, you have no problems, right? There are some good calculators, and even online you can have a calculator like that, and you have a fraction to deal with. You can do it inside your calculator. Does your scientific calculator that you have with you, does it do fractions? Can you feed in something like 3.5 and 1 4/5 and so? Can you do that?
Yes, sir.
Oh, you're saying yes? Okay, so if your calculator can do it, make use of it. Right, and let's go to multiplication. If you have, again, let's say, all right, you have to multiply 2 and 2/5 by, let's say, all right, 15 over 16. Let's say you have that, right? Well, you can cancel fractions. You can cancel 2 and 16. You can cancel it 5 and 15. And then you simplify 1 by 3, you get 3, 1 by 8, you get 8, and that's your answer. All right, easy. This is easy. If you
Yes,
have
sir.
first,
Sir.
you have 1.5 multiplied by 2 and 3/4, right? Well, you can do it different ways. You can multiply the 1 by the 2, right? And then the half by the 3/4. Or some people would change, they change both of these to improper fractions. So you have 1.5 is 3 over 2 multiplied by 2 plus 8 and 3, 11 over 4, right? And what you have, anything can cancel, you know, so you only have it some horrible looking. You get 33 over 8, which is 4 and 1/8. Right? There's a harder approach, and I wouldn't bore you with it until you do when we do quadratic expressions, because this here can be written as 1 plus a half times 2 plus 3/4, and that's a little more complex. Don't worry. This is much easier, this approach, right? Don't worry with this here. Later on, you'll come to appreciate that something. Good. When it comes to division, let's say you have to divide 1.5 divided by, let's say, 1/4. Dividing by a fraction is the same as multiplying by its reciprocal. It's a basic fact, right? So what you do, you take this 1.5, that's 3 over 2, and multiply it by the reciprocal of 1 over 4, which is 4 over 1, right? And you do your normal cancellation, 2 1s, 2 2s, so you end up with 6. Right? 6 over 1 is the same 6, right? If you have, or let's take another one, 2 and 1/3 divided by 1 and let's say 1/6. Same thing, you can convert everything here to improper fractions, so you'll get 7 over 3 divided by 7 over 6, that's right? Which is the same as 7 over 3 multiplied by 6 over 7. 7s will cancel out. 3 1s, 3 2s, and you end up with 2, right? 2 over 1, which is 2.
Excuse me, sir.
Yeah.
When it for the part where you have 7 over 6, then we had to like upturn the last fraction here.
And didn't we do that? We didn't do it? 7 at the bottom, 6 at the top.
Yes, sir, you did upturn it.
Okay. Yeah, so that's the bit there on adding, subtracting, multiplying, dividing fractions. As I said, if you have problems like these and you have a calculator that can do it for you, don't waste time with doing the arithmetic that I'm showing you. Use the technology, right? Even CXC, the questions that they give you, they'll tell you use a calculator and you can, and people do it all the time. You're working on a job, nobody expects you to do, well, one of the girls said her boss is like that. I don't know who's that boss. Because nowadays you pay people, you know, the less time they can take to do a task, the better. I don't want you to be adding numbers on paper, taking, you know, half an hour. If you can do it in minutes, so you can do another task, well, that's what you have to be doing. I don't understand the economics, right? But then there are lots of other operations that aren't stated explicitly in the course outline, but like, okay, let's say you have fractions there, right? And somebody say, well, all right, express uh, 6 all right. I think I choose an ugly leave it alone. Express 3/8 as a decimal. Let me just say that. What will you do to write this as a decimal? Any ideas? What will you do to express it as a decimal?
Sorry, I gotta do short division, I guess.
Again, if you have a calculator in your hand, just divide 3 by 8.
Yeah, just use the calculation. And you get 0.3775, yeah, 375.
If you have a calculator, don't waste time. You have the world of work to do at your workplace. Why are you doing this by long division or short division? Or as somebody says, let's do the, what do you call it? Some people put it like this. What's that? 3 divided by 8, right? So there's a point there. Just put a point back here. So 3 divided by 8, 0, you add a naught. Then you say 30 divided by 8, right? Which is what? 4, no, 3/8 is 24, right? 24, add another naught here, right? 24 and what is 36? 60 divided by 8 is what? 7, right? And you add another naught, how many remain there? 8, 7 is what? 56. You have 4 there. So 40 divided by 8 is 5. Is that it? Right?
Yes,
That's the division.
Yes, sir.
You can do long division as well, but why are we doing this when you can just punch this in a calculator and get your 0.375, right? You can do that. You can do your long division. You all probably know that too. You just do it like this. 3 divided by 8, you put a point there, and you put a point there. 3 divided by 8, 0. Right? And you add a naught there. 30 divided by 8 is 3. 3 is 24. 6 left back, you add a naught. Right? 60 divided by 8 is 7. Then you get your 56. Subtract, now you get 4, you add another naught. 8 into 40 is 5. Right? And there is 0 now, right? Long division or something like that, they call it, right? But gone are those days. You're not going to do this at your workplace. Don't do this. You have a calculator, punch it in quick. Right? Again, if you have something like this now, and there are so many variations to the problem. You have, okay, you are asked to express 1 3/4 as, not 3/4, let me use a horrible one here. You can quickly guess it. 1 and, let's go with 4/5 as a decimal, right? Again, there are more than one ways. You can change this to an improper fraction and you get what? 9/5. And you do the long.
1.8.
Huh?
I got
And
1.8.
say it again.
1.8 I got.
Oh, okay. I'm just saying, right? You can do your long division or your short division, and you will get your 1.8, right? Sometimes what you could do is take 4/5, right? Express 4/5 as a decimal, and you will get 0.8, 0.8. And then there's a 1 in front, so you just put 1.8, right? You get it? Make use of your calculator extensively. Then you can have something like this. You can be asked express 4/5 as a percentage. Anybody knows how to do that? Hmm? What do we do there?
Is it like
Sir,
4/5
multiply by
times 100 over 1?
80%.
Exactly. Yeah. 4/5, 4/5 multiplied by 100%, right?
80%.
1, and you do your thing, you can put punches in the calculator. 4 by 100 divided by 5. Some people were going to cancel out 5 ones, 5 times 20, then multiply that and you get 80%, You choose what you want to do. So we talked about how we can take a fraction, make it into a decimal. We talked about taking a fraction, writing it as a percentage. We can have the reverse as well, right? We can have, okay, write 1 point, let's go with a simple one, 1.25 as a fraction. Sorry, not a fraction, mixed number, right? And there's a shortcut where you have to understand that this really means 0.25 is 1 plus, this is really 2 by 1/10 plus 5 by 1/100. But nobody does this, right? Nobody does this, right? Because this will add up to be 1 and 25/100. Everybody do the shortcut thing where they take this 1, okay, right? And where the decimal point is, okay, they put a 1 in the denominator. Each digit after the decimal point, you add zeros for them. And then you put the 25 over the 100, right? But it's not done yet. You have to reduce it, right? Which is equals to 1 1/4. As you can see, right? The 1/4. Same thing here, 1/4. So you can be asked something like this, the opposite of, instead of taking a fraction, writing it as a decimal, you can be asked to have a decimal converted into a fraction. You're following so far?
Yes, sir.
Yes.
All right, what about you? You were asked this now. Express 35% as a fraction. Look at that. What will you do?
So this way I have might be longer, but can you like take the 35 over 100, divide it, and when it turns into a decimal, you basically do what you did before to make it into a fraction.
Well, you can put it 35 over 100 and just cancel down, right?
Right.
A fraction. So 5 sevens, 5 20, so you have 7 over 20, right?
Right.
Yeah. I like that idea you have there, Justin. If you were asked to express the 35% as a decimal, you put it 35 over 100, which is 0.35, right?
Right.
Yeah.
Yeah.
These little things you must know, you know. You can't talk about arithmetic without knowing these things. So even though you have your calculator, you must know what you're doing. Later on, you will see, okay, we have to find a certain percentage of another number. Like, I'll show you some examples just now. It'll involve some fractions. Huh? I hope everybody else is following, right? And make your comments as to whether you get it or not. So let's say you have something like this. You have, all right. Find, okay, all right, let me go to a fraction one. 3/8 of 30. You know, what do you do here?
33 over 8 times the 30.
Exactly. 3 over 8 multiplied by 30 over 1, right? So what can we do? 2 into 8 is 4. 2 into 30 is how much?
15.
Okay, so we'll get what? 45 over 4. What is that? 11? Or 11 44 and a quarter? Right?
Yeah.
Ugly answer, but that's the answer.
Hmm.
Right? You don't have to do all this cancel. You can work this in your calculator. 3 by 30 divided by 8, right? And get, but you might get 11 and a quarter, you might get 11.25 in your calculator. And you'd have to know, well, that 0.25 is a quarter. You'd have to convert it. But these are all different operations that you can see involving fractions. The possibilities are, you know, very many. Let's say you have another one. Find 25% of 250. Let's say dollars. Let me use some big money. 250,000. 25% of that.
Okay, so you put it
Sorry,
25 over the 100, you times it by the 250,000, and you cross off the zeros that remain from the 100 and the 250,000, and you times it by 25.
Yeah, you can do that. That's 2, yes, and that 2. 25 by that, and you get an answer here. That's one way. You don't have to do any crossing off. You can multiply the 25 by the 250,000 and then divide by 100. The calculator can do that. Give me an answer for anybody who's trying it.
62,500.
What is it? 52,500?
62,500. 62.
Oh, 62. All right. 62,500. Yeah. Right. So you see, again, fractions coming in to these calculations. So yeah, fractions have so many applications. Right. So understanding how to move from one to the other, how to, work with percentages, work with fractions, work with decimals. You want to be able to move from one to the other quickly. A common problem you see is this, like over somebody says, arrange these numbers in order. Arrange the following in, let's say, ascending order, meaning from smallest to the largest, right? Order is clear. Let's go with some. So we have a half, 0.37, 40%, 5/8. Let's say somebody tell you arrange those in ascending order. What will you do? Any ideas? What?
That's the answer.
No, I'm asking you, what will you do? Don't tell me the answer. Tell me, what will you do if you have a problem with it?
First thing first, you break down all the numbers, like what don't the decimal, and then you see which number is small, and then arrange it from ascending to descending.
So you're saying write all of them as decimals.
Yes,
Then you can
sir.
see
Sure.
which one is
Yes.
higher and which one is lower. That's a good idea because, okay, half, you punch it in the calculator, you get 0.5. All right. This one is 0.37. 40% is 0.4. Or you want to put a mark here. 5/8 is what as a decimal?
0.6.
0.6 what?
0.625.
625. And the numbers are in ascending order here, right? No, this is the small.
No, sir. That's wrong.
So ascending order. All right. Ascending order, right? So this is the smallest, 0.37. Then you'll probably go with 0.4, then you'll go with 0.5, and then you'll go with 0.6, right? 25. So that's one approach. You can change all to decimals, which is the easiest thing, especially if you have a calculator in your hand, right? And then, of course, you can write them back because sometimes, let's say the multiple choice, they might give you these. You'll have to write them back. 0.37, 40%, then half, and then 5/8. You know? All these are kinds of problems people can ask you about fractions and decimals and percentages and so, right? And you want to be able to handle these kinds of problems. Because you can't say you master arithmetic and decimals and fractions and percentages and so trouble you. Sometimes you can be asked this, okay? Which of these fractions is greater, or sometimes you can be given two fractions. Let's say 7/8. There's a box, and let's go with 8/11. Let's just say, right? And they ask you to, all right, insert a greater than or less than sign in this box here, in the box. So what sign will you put in there?
Seven eighths is greater than 8/11.
It's greater than. How you know that? How you know? How do you know that? Because the method is.
Because when you divide 7/8, right?
Oh,
It
you
will
did
be
it in the
0.
calculator.
Yeah, when you divide, right, 7/8, it will be 0.875. And when you divide 8/11, it will be 0.727. Therefore, 875 is greater than 727.
Okay, so you use what she did. She converted this to a decimal. And what is it? 0.
Which is 0.875.
And this one is
0.727.
okay, 7 to 7.
27.
Go. And you decide that this is greater than that. That's one way, right? I saw a nice trick today. I was watching, sometimes you watch these little tricks people got. Watch this. If you multiply this number by this number, you get 77. When you multiply this number by this number, you get 60. 88 is what? 64? So the fact that 77 is greater than 64, then this fraction is greater than this fraction. And there is a little bit of arithmetic behind
Sir,
it.
I get that. Can you just go over, please?
What, this thing here?
Yes, yes.
I'm telling you, it's a trick, a shortcut. You multiply the 7 by the 11 and the 8 by the 8, right? And the fact that the 7 by 11 is 77, which is greater than the 8 by the 8, then the first fraction is greater than the second fraction.
Okay, sir.
If I have to use a simpler one, let me go with a simple. A half box and a quarter. You know that a half is greater than a quarter. So let's see. 4 by 1 and 1 by 2, right? So you get 4 is greater than 2. Therefore, this fraction, half, is greater than a quarter. Right? That's a little trick that you can do it fast. But going back to the one we had already, I think we had what, 7/8 is greater than, what was it, 8/11?
Yeah, 8/11.
Yeah. Now, some people can abstractly in their mind, they can see that, okay, this fraction is 8s, right? We're dealing with 8s. So if we were to, take a piece of thing here and divide 1, 2, 3, 4, 5, 6, 7, it's 8, right? Let me erase this piece. And then they were to take this and just go with 11s now. Oh gosh. So I have to draw it maybe right here.
So that really primary school thing you showed us.
Yes. If you were to divide it into 11s now, and you do 8 11s, you will see that it's actually less than 7/8, right? That's the other thing. If you can picture it. I couldn't draw it, I said. But yeah, you divide it into 11s. 1, 2, 3, 4, right down to 11 parts. You will see that 8 11s is actually less than 7. That's a small children trick that they might teach you in primary school and so. Good. So that's a nice review of fractions there, right? I don't want to introduce anything new to you, right? That involves, well, we were supposed to go on to some algebra now. But I don't want to overload you with stuff, right? We'll deal with that another day. So before we close though, I want to talk about what we did last week. Not last week. Yes, last week, right? I forgot the date. Today is what day?
Monday, sir. Monday, not last week.
And today is not Monday?
Yeah,
Oh,
sir,
sir,
last
last
week.
sir. Yeah, last week, sir.
And-
Sorry.
So we talked about, let me go back, everything properly. Let me just watch back there. Yeah. We talked about the order of arithmetic operations. Today we talked about fractions. Then we talked about the decimal systems, and then we talked about directed numbers. Right? So yeah, so let me go those back. So we talked about the order of arithmetic operations, right? And I want you to remember the order, bod, mass. Right? Let's start with that. That's a review. What does the B stand for?
Power of numbers.
Bracket.
Bracket. So you work out.
Power of numbers.
No, the B. Work
Yes,
out
sir. Bracket. Bracket.
operations in the brackets first, right? And all we said after that, after you finish doing that,
Power of numbers.
yes, you work out powers of numbers, right? Powers of. So your O comes. Then you do division.
Sir, a question.
Yeah.
When it said power of numbers, we know mostly of in terms of maths is basically multiplication. Is that so? Because we know M is multiplication. So if it's power of numbers, isn't it dealing with multiplication?
Yeah, in a way, yes. You have to raise a number to, let's say, 2 to the 4th power. It's the same as 2 multiplied by 2 multiplied by 2 multiplied by 2. Yeah.
Okay, great. Yes, I understand.
Yeah. Then division, then multiplication, right? Multi, M-U-L-T-I, multiplication. I should write that one, multiplication. But I mentioned if these two come together, if these were to come together, right? You work them in the order in which they appear, right? So if multiplication comes before division, you can do them in that order. Do the multiplication, then the division. If the division comes first, do the division, then the multiplication, right? If you're adding next, you have to add positive numbers first, right? When I say first, I don't mean before brackets and so before subtraction. And then lastly, you subtract, right? Last, subtract last. Subtract last, right? Again, if the two come together, you can do them in the order they appear. Do them in the order they appear. And we're going to show a number of examples with that, right? So remember the BODMAS rule. Different textbooks, sometimes you watch some video and so they have some different things that they show you. They all will add up to the same thing. So that's the order in which you do arithmetic operations. Some calculators and some programs understand the order and how you feed in the thing. You can feed a problem in, right? Just like you see it, and it will give you the answer. Some calculators don't, right? Maybe I should test it. Everybody has a calculator with them.
Yes, sir.
But this is what I want you to do. Let's try this. I want you to feed this in your calculator. I want to feed this in the calculator, everybody. And let's see what answer you get. Because some calculators don't understand, or not the calculator don't understand, it's programmed in a way that you have to feed in the operations in the right order.
Sorry again, negative 28. You know, if
I have
anybody.
negative 60.
Mine is 60.
I got
Negative
negative
60, sir.
60.
Negative
Somebody get negative 60. Who else?
Negative 60, sir.
Everybody get
Negative 60, sir.
all right.
negative 60, sir.
Well, let's see if that's the real answer, right? So according to the rule, going with BODMAS, remember, we're going to work out what's in the bracket first, the operation in bracket. So you get 4 subtract 2, right? There's a multiplication sign here, even though we don't normally put it, right? So we're going to put it down. Times 3 plus 5 is 8, 8 square, multiplied by 2, divided by 4, right? Our next step is to work out powers of numbers. So you got 4 minus 2 multiplied by 64 multiplied by 2 divided by 4, right? So next we have to do these operations, right? And we can do them in the order in which they appear. So we have 4. How did we change the red now? Subtract. And can you work all of this out for me? 2 multiplied by 64 multiplied by 2 divided by 4. And tell me what the answer is. Okay, it's supposed to be 64. Because this 2 by that 2 will give you 4. 4 divided by 4 is what?
64, sir.
Yes. So you get negative 60. So it seems the calculator seem to understand or seem to be interpreting what you feed into it. And applying BODMAS to its calculation, which is good. Long ago, it never used to do that. Right? Sometimes the calculator will actually take the 2 out from the 4 first. Right? It will do that. But now I guess the guys who write the program, they refine the program in such a way that it actually obeys the order of arithmetic operation, which is good. All right. Good. So today we talked a lot about fractions. So I guess, yeah, we don't have to do any more with fractions, right?
No, sir, I understood everything that was taught.
Yeah. So that was a nice review of fractions. I think you shouldn't have problems there. And then we went on to talk a little about that was last week, right? We talked about the decimal system, right? It's not decimal currency. I think there's an error in the course outline. It's a typographical error. And what the decimal system is all about really is where numbers, right? The place value of each digit in the number is a power of 10. So let's see, all right. Let's take a number. 1,250.125. what is happening here is that each digit, right? The place value is a power of 10. So, okay. Down here, the power of the 0 is 10 to the 0, right? Or what I call ones. The place value of 5 is 10 to the 1 power. Place value of 2 is 10 to the 2nd power, which is 100. The power of the 1 is 10 to the 3rd power, which is 1,000, right? The 1 here is 1/10, which is 10 to the -1. The place value of 2 is 1 over 100, which is 10 to the -2. The place value of 5 is 1 over 1,000, which is 10 to the -3, right? And that's why they call it a decimal system. Deci carry the idea of tens, right? So the place value of each digit in a number in the decimal system is a power of 10. That power can be any integer, positive, negative, 0, all of that, right? And we talked extensively about if you have to add, subtract, multiply, and divide decimals. What was my advice to you? What was my advice to you?
Use the
With the
calculator.
calculator.
Exactly. Unless if you are a teacher in a school trying to teach elementary children, primary school, and you're teaching them how to add decimals, or decimal numbers, or subtract, or multiply, or divide. Only then will you want to go down to paper and so on. And think about if you have something like this: 2.25 divided by 0.15. And you have to do this on paper. It's going to be very tedious. But your job and whatever endeavors you want. I mean, if you have to end up being an elementary school teacher, when you go to college, they're going to drill this in you. They're going to show you how to do it a long way and how to teach those little children how to do it. But you are not an elementary school teacher. And even if you are an elementary school teacher, this course is not here for really teach you that method, right? You make use of your calculator and do any arithmetic that involves decimals, use your calculator. You're free to do it. And we did talk about how to convert decimal numbers. Like I said, okay, we have 1.5. How to convert that? Convert 1.5 to a fraction. We just talked about that, right? So what do you do? The 1, well, it's not a fraction, it's a mixed number, right? So you have 1 and the 5. Remember, the 5 is like, it's in the 1/10 is the place value. So it's 1 plus 5 times 1 over 10, which is 1 and 5/10, which is 1 and a half, right? Alternative to that, the shortcut they tell you again in primary school is to do this. Take the 1 and where the decimal point is, put a 1 in the denominator. Each digit after the decimal point, put a 0. Put the 5, the digit there, and then reduce it. So you have 1, okay, 5 1s, 5 2s, 1 and a half. Right? These are all ways you can do that.
Sir, kung go over that ba?
I was showing you 2 approaches. Let's go back. Let's start from scratch. You have 1.5. What you have to understand this to me, this is This here, this 1 is 1 times 10 to the 0 power plus the 5 is in the position of 10 to the 1, sorry, 10 to the negative 1 place, right? If the place value of the 5 is 1/10 or 10 to the negative 1. So this one is 1. 10 to the 0 is always 1 plus this means 5 multiplied by 1 over 10, which is 1 plus 5 over 10, which is 1 and 5 over 10. And you reduce this 1, 2, and you get 1.5. This is what I tell you in primary school, right? Alternative to that, the shortcut is you put a 1 and you put, where you see the decimal point, put a 1 here. Every number after the decimal point, put a 0. Then you put a 5 up here, the digit up here, and you reduce this, which is 1.5. So this is if you're talking, you know, you're going through the long approach, you're going to use the place value of each digit. The place value of the 1 is 10 to the 0, which is 1. The place value of 5 is 10 to the negative 1, which is 1 over 10. This is the long approach. People would hardly use that. People would use the shortcut like this here. And then we talked about you want to convert 1.5 back to a decimal, what to do. Right? You take the half, punch it in the 1 divided by 2, you get 0.5. And you put a 1 in front of the decimal point. Right, so we talked extensively about fractions, how to convert one to the other. We talked about percentages, how to convert fraction to percentage, percentage to fraction. We did all of that. And then I remember the last day we spoke a little about directed numbers, right? And you're saying that those are basically negative and positive numbers. You have a 0 there, you know, and coming back this way, and so on. This one goes on and on, right? Of course, you can have negative 1.5, you can have negative 1 3/4, you can have it written like that, right? You have 1.3, you know, 1.25, you can write it like that too, right? And in particular, if you're not dealing with decimals and fractions, we talk about how you can add them, how you can subtract them, how you can multiply them, how you can divide them. Did you see that in the notes that I sent to you? Anybody? You didn't see that in the notes. I sent some notes to you.
Yes, sir.
Yeah. So again, I said, if you can't grasp the rules, use your calculator, right? Negative numbers can be fed into your calculator very easy, right? But the rules, I think I explained some examples. Let's say you're adding, you have.
Yeah,
Okay.
sir,
Uh-huh.
but we can, yes, we can use our calculators, but when it comes down to the point of explaining how you get the answer, especially in your CXC paper 2, that's another thing. So wouldn't it be, I guess, useful to learn the longer ways too?
I told you already, you don't have to explain on a CXC paper. You write CXC before? Let's
Yes.
give an example. Let's put something here. Negative 7 plus 3 minus 2. If you have a question like this in CXC, right? You think they're gonna ask you how to do this? They expect you to punch this in your calculator, get the answer quickly. I think I showed you that. They expect that you will use your calculator.
Right, but not also put down how you got the answer.
You
Like
know, as I told you, sometimes they give you 1 mark for this. So how much?
right, you look at the ones with the marks. With some of them, like these, this one here has like 3 marks. And you just punch in what is in the calculator and just rest it there.
Have one in front of you? You have one in front of you?
No, not on me right now.
This one? Yeah, you will never see a question like this in a CXC paper, right? It'll be much more complex, right? As I said, you have to know, I mean, it's good if you know the rules, but I'm saying if your back against is against the wall, right? And you have a calculator, why are you worried about rules? Right? So you use your calculator, you feed this in, right? I think you press in 7, then you press the minus sign, right? That will feed the calculator -7 plus 3, right? If you want to, you apply the rule here and know that a negative and a negative will give you a positive, all well and good. But if you were to do this in the calculator, put in minus, open bracket, another -2, close bracket, the calculator will understand, right? And give you the right answer. So whether you use your calculator directly, or you make use of the rule where you take these two negative and it becomes a positive. If you want to do the next step the hard way, because you look like you want to do the hard thing. So -7 and 3, well, these two signs are different, right? So you have to find the difference of the two, which is 4. The sign on the one with the larger magnitude is -4, right? So you put then the +2 at the end there. Again, you have to repeat the procedure. The signs are different, so the answer is 2 here, and the sign on the one with the larger magnitude is a negative. If you see a problem like this in CXC, the people give you 1 mark. Why are you doing 1, 2, 3, 4 steps for 1 mark? Right? And as I told you, I showed you, let me show you. I did show you that, right? That the mark scheme
Yes,
has
sir.
1 mark, right? Let me just show you back something. Wait, I want to show you back something. Right? Let me see if I can. Let me get back this desktop. 1 second. I just want to show you something. This, what I'm showing you here, is a mark scheme for this year's CXC, the GON. I don't know if anybody wrote this exam. So you have to do this calculation. You have to calculate the square root of 7.1 squared plus 2.9 squared. And you have to give your answer to two significant figures. That's the first part. Are you seeing here? Do you see what marks they're giving you here? They give you 1 mark. And they're giving you this 1 mark for just this answer here. Right? So all the marker is interested in writing down all of this doesn't matter. What they want to see is that you have taken the calculator, punch this inside somehow, get 7.66. You don't have to write all of this. You don't have to. There's no mark for it. Do you see it blank? Do you see it's blank? There's nothing here, no marks for it. My friend, are you seeing what I'm showing you?
Yes, I'm seeing it, sir.
Yeah, there's no mark for none of these steps. Watch. The square root of 50.41 plus 8.4, no mark. You see? The square root of 58.8, there's no mark allocated to it. So if you were to write down, right, that, okay, this is the first step, and don't waste time. In CXC, you don't write back 7.1 square plus 2.9 square root. That is a waste of time. That's already in the paper. Don't write that back. You are wasting time. If you put that equal to 7.669, let's just say that. They don't care that you have this here. They don't care that you have this third step. When you take 7.669 and round it to 7.7, they will give you 1 mark. They do not care for all these steps. So you don't have to detail all of that to them. They expect that you are at the level where you have a technology in your hand, a scientific calculator, and you can punch that whole problem in and get 7.669. What they're testing here is that you can now take 7.669, whatever, and round that to 2 significant figure, which is 7.7, right? And here is where they'll give you the mark. You see, R1 dash correct answer only. You can write all of this, and if you don't write 7.7, you get 0. You can have all those steps. And if you don't have 7.7, do you notice? They're only going to give you this 1 mark. If you have, you see the CAO, it means correct answer only. They're not going to give you no mark for all these steps. You get what I'm saying?
I understand that, yeah.
Yes. So you don't have to worry that you got to explain the rules of arithmetic to a big CXC marker. You are at university. Why do you have to explain that to anybody? They expect that you already know that. You get it? Look at this next question. Watch. They want you to take all these numbers and put them in ascending order. How many marks they're giving you? 1 single mark. They don't care. They don't want to see you taking all the numbers and converting it to decimal. They don't care. Do you notice in the step? This is the answer, right? So they just take it, they put it in ascending order. They give you 1 mark. So there's no need for you to show all the working. You
Just
can
drop your answer and move on. That's what you're basically saying.
Yes, that's it. If the people give you 1 mark, you should know they only want the answer.
Okay, good.
For you to
So
arrive,
basically, you're saying to understand how this testing, this whole marking work, just by looking at how much marks you get, you don't know, okay, this is how much effort I should put into this question.
exactly, you are a discerning person. Yes. When you see the people ask you, they get 1, 2, 3, 4. I think it's 3 things, right? Yeah. 12 over 25, 0.46 and 47%. You don't have to show them nothing. You could do that in your scrap. You see this next step? 12 over 25, they punch it in the calculator and they get 0.48. Well, 0.46, they're right back. 47%, they put 0.47. If you write this step, but you at the end put the things in the right ascending order, as you see here, 0.46, then 47%, then 12 over 5. The person marking has to, let's call it, seen or implied. How does the child come up with this? Is the child a magician? No. The child had to take some scrap paper somewhere and work it out. And that's how they arrived at the right answer. They can't assume that the child guessed. In a court of law, you can't tell me you guessed the answer. How do you know I didn't work it out in my brain, sir? How did you know I didn't work it out on a scrap paper? Which wasn't submitted to CXC, it was thrown away in the garbage. You can't know that. You understand?
Yeah.
Is that you go to the shop with $1,000, the shop man can say, your thief, you more money. The shop owner can't just tell you that. You got $1,000 there for your thief. You can't do that. The police can't always watch you and say, you, like what they do in America, because you have a certain color, you are a criminal. You understand? So
Yes, yes.
the point I'm trying to make here is that you don't have to show. There are times when you have to show that, like as you go on in the thing, they might tell you where they'll ask you. Let me see, they'll ask you. They might ask you in the question. I can't find one right now. To show all working, they ask you for that. Well, that's another thing, right?
Yes.
Is that clear?
Yes, it's very clear.
Yeah. Well, back to our thing. Yeah. Back to our thing here. Yeah. So if your back is against the wall and you don't know, you can't remember the rules that you know what, this negative and this negative will reduce to a positive and so on. Why do all these steps when you can take this, punch it in the calculator and get your answer? 1 mark and you're done. You get me? But it's good to know the rules, especially if you want to teach someone. Like, okay, you have, all right, 2 positive numbers, 7 plus 2. All right, both of them are positive. 2 numbers are the same sign. Add them together, keep the sign of the 2 numbers. If you have 2 negative numbers, add the 2 numbers, 6, keep the sign. Those are rules. If the 2 signs are different, -7 plus 5, 2 signs are different, find the difference of the 2 numbers, 2, keep the sign of the one in the larger magnitude, negative, right? If you have 2 signs, okay, 7 minus 3, take these 2 signs, 2 negatives is a positive, so you have 7 plus 3 equal 10, no? Right? If you deal with multiplication, a positive multiplied by a positive is a positive. A negative multiplied by a negative is a positive. A negative by a positive is a negative, right? A positive by a negative is also a negative. When the signs are the same, the answer is positive, right? See, signs are the same, answer positive. When the signs are different, the answer is negative. When the signs are different, the answer is negative. Same rule applies for division. Positive divided by a positive gives a positive. A negative divided by a negative gives you a positive. A negative divided by a positive is a negative, right? A positive divided by a negative is a negative, right? Same rules apply. As I said, if you can't remember the rules, you have a superpower, a supercomputer in your hand, calculator, right? When I give you your test, you will have your calculator right at your house. You have all the textbook, you have all the internet, you have everything in front of you.
So sir, it's
So
like we just put in the answer on the paper, no more fast way and we done.
if I tell you that I want to see the steps how you arrive at the answer, well, you'll have to show me. If I don't tell you that, right? Well, it's up to you. And your test might very well be a multiple choice test. The answer is right in front of you. You don't have to pick it out.
Sir, so it's only multiple choice only?
I'm not saying that will happen with you, but I'm telling you, in the past, I've given multiple choice tests where everybody, you just have to pick out A, B, C, or D,
Okay, sir.
right? I may give you something to write. I may. Good. So we talked there about directed numbers, right? So yeah. Good. So yeah, that kind of round off our lesson for today. Let me just stop the recording. Are you sure you want it? Yeah.